All right, here we go in our very first section of PreCal. We're going to start in Chapter 5, Section 1 with a focus on trigonometry. And trig functions are focused on angles. We're going to talk about how we position our angles in the standard position. We're going to talk about right triangle trig and oblique triangle trig. But we're going to start with a lot of definitions in this very first section. If you took trigonometry already as a course, then about the first half to 2/3 of this class is going to feel like a review. If you didn't take trig, it may feel a little rushed because we do introduce a lot of concepts fairly quickly. Trig is an extremely applicable branch of mathematics. You see those studies of angles and measurements a lot in engineering. And the people who lay out our highways and our road systems, a lot of different fields are going to use trigonometry. So we're going to start with some very important definitions that for some of you will be a review from a previous trig class. For others, they may be a review from geometry. A ray is a portion of a line that starts at an end point and extends indefinitely in one direction. That starting point is its vertex. So this ray starts at the vertex V and extends forever in this direction. It falls on this given line, but it's not the entire line, it's just part of a line. If two rays are drawn with a common vertex, then they form an angle. One ray is called the initial side. That's where we start measuring our angle. And the other ray is called the terminal side, and that's where we stop measuring our angle. The angle formed is identified by showing the direction and amount of rotation from the initial side to the terminal side. Standard if we have it in standard position, we are typically going to be measuring from a counterclockwise direction, and that gives us a positive angle measurement. If we rotate clockwise, we get a negative angle measure. So, for example, for this angle, at this vertex, we start at our initial side and we show that we are going to measure the angle from the initial side to the terminal side. Now, if we move this direction, we're moving counterclockwise and we have a positive angle measure. However, if we move from the initial side to the terminal side out here, we're moving in a clockwise direction, which gives us a negative angle measure. Notice that we haven't moved the angle. The angle is exactly the same, but the measurement we get is going to be different. For example, let's say that this is 30 degrees. Well, if this is 30 degrees, then what is the measure of angle beta? Well, since it's this outside larger angle, and with this 30 would make a full circle, this is going to be a negative 150 degrees. Negative because we used a clockwise rotation. Now, what if we go past the terminal side? Angles of rotation, we're going to work with these a lot in trig. Notice that I start at my initial side, I rotate in a counterclockwise manner, but I go past that terminal side and come back to it. So I've done a full rotation, oh my goodness, I've already made my first mistake of the day. A half rotation is 180. A full rotation is 360. I've been focusing on my Math for Teachers classes, and we've been doing triangles and the angles of a triangle that add to 180 degrees. Hopefully some of you have been sitting there going, oh my goodness, she totally missed that. This shouldn't be a negative 150. This should be a negative 330. There we go. So a full rotation is 360 degrees. If this 30 degrees is positive between the shortest distance between the initial and terminal side, if I go clockwise on the longest distance from the initial to the terminal side, I've gone 330 degrees. It's negative because it's in a clockwise direction. All right, now that we've got that established, for this third angle, I did one full rotation, which is 360 degrees, plus that 30 degrees again, which makes this angle of rotation 360 plus that 30 for a total of a positive 390 degrees for this angle of rotation. Okay, now you're going to find Greek letters a lot as we work through calculus, pre-calculus, and trig. Notice it's quite common to use Greek letters to denote angles, so you need to know what we're going to name these angles, what we're going to call these angles. This Greek letter is alpha, then we have beta, and we have gamma. These are going to be three of the common ones that you see used. Okay, an angle theta, we're just going to name our angle theta with that Greek symbol, is said to be in standard position if its vertex is at the origin of a rectangular coordinate system and its initial side coincides with the positive x-axis. So I'm in standard position if my angle is seated at the origin with the vertex of the origin and the initial side is the positive x-axis. Here, if I measure this direction, I have a positive value for theta. And if I go clockwise, you see I have a negative value for theta. When an angle theta is in standard position, the terminal side will either lie inside a quadrant, in which case we say that that angle theta lies in that quadrant, or on the x or y axis, in which case we call theta a quadrantal angle. Quadrantal angles are special angles. And they're easy to memorize because each quadrant is 90 degrees, right? So this is going to be 90, 180, 270, 360, and then I could keep going by adding another 90 and get to 450, etc., etc. Or if I rotated clockwise, I would have negative angle measures. Let's just take a second and let's talk about our XY coordinate plane. Our XY coordinate plane, where we have the x-axis is horizontal and the y-axis is vertical, we number our quadrants starting at 1 o'clock on the clock and moving in a counterclockwise direction. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Any points or angles that fall in quadrant 1 are going to have coordinates that are both positive. X and y are both positive. If I move over here to quadrant 2, x is negative, y is positive. Quadrant 3, x and y are both negative. Quadrant 4, x is positive, but y is negative. Now, if I have angles that fall in these quadrants, anything in the first quadrant is going to be an acute angle. Anything that falls in the second quadrant, because it measures more than 90 but less than 180, is going to be an obtuse angle. And remember, 90 is a quadrantal angle, 180 is 180 degrees is a quadrantal angle. Anything that falls in quadrants 3 or 4 we call a reflex angle. A reflex angle is larger than an obtuse angle, so it's going to be greater than 180 degrees, less than 360 degrees. If I go beyond that, acute, obtuse, reflex, if I keep going around, like for example this one, we call that an angle of rotation. Okay. Let's look at our next page. This gives us an exploration to do, and we're going to talk about how our unit circle is going to work. Now, in either a video, if you are not in a lecture class, or if you are in a class with a lecture component, we will cover working through our unit circle and filling it in during our time together. Thus far in your career, you've probably measured angles in degrees. 360 degrees represents one complete counterclockwise rotation. Counterclockwise because it's a positive 360 degrees, 360 not 180 like I started out with today. This means that 1 degree is equivalent to 1/360th of a complete rotation. So 60 degrees is going to be 60 out of 360ths, or 1/6 of a complete rotation. Notice that my degree symbols divide out, they cancel out. From this it follows that a right angle is 1/4. 90 out of 360 simplifies to 1/4 of a complete rotation. It's going to be 90 degrees. A straight angle is 1/2 of a complete rotation and is 180 degrees. Using this information, figure out about where each angle would fall and what quadrants it's in. Well, for A, it gives us 135 degrees. It's positive, so we're going to start at our initial side, our positive x-axis, and we're going to rotate 135 degrees. When I rotate to this y-axis, that's 90, and 135 minus 90 gives me 45 degrees, which would be halfway through the second quadrant. So 135 degrees is going to be about right there. What about a negative 120? Well, that negative means that I'm starting at my initial side on the positive x-axis, but I'm rotating clockwise. Well, again, if I rotate to the y-axis, that's 90 degrees, and that means I still have 30 more degrees to rotate. Well, 30 degrees is just 1/3 of the way through that next quadrant because it's 1/3 of 90 degrees. So we're going to say right about there is going to be a negative 120 degree angle. Okay. Now, when you have talked about measuring angles in the past, you've probably stopped at the idea of measuring angles in degrees, but you can get more specific. Fractions of a degree are represented in minutes and seconds. Now, those word minute and second used in this context don't really talk about time. Degrees, minutes, and seconds are used for things like latitude and longitude. So if you've ever done anything with GPS coordinates, you've probably seen measurements like this. So we want to be able to convert degrees, minutes, and seconds to decimal form and then back the other way. In a full circle, there are 360 degrees, and each degree is split up into 60 parts. Each part is called a minute. 1 minute denoted by 1 with an apostrophe. So just like with length measurements, you would do an apostrophe for inch or for foot, and in a quotation 2 of those for inch. We do 1 for minute. We're going to do 2 for seconds. So this is going to be 1 minute. That is 1/60th of a degree. So 60 minutes is equal to 1 degree. And 1 second, like I said, we've got 2, it's like a quotation mark there, is 1/60th of a minute. So there are 60 seconds in 1 minute. Well, if there are 60 minutes in 1 degree and 60 seconds in 1 minute, how many seconds are there in 1 degree? Well, for each minute, I've got 60 seconds, and it takes me 60 minutes to get 1 degree. So it takes 3,600 seconds to equal 1 degree. Okay, let's look at example 2 on the next page. Convert between decimal and degrees, minutes, and second measures for angles. Okay, so we're going to round the answer to 4 decimal places, it tells us. That gives us a place to start angling for. No pun intended. We're going to convert 45 degrees, 10 minutes, 15 seconds into decimal form. Okay, well, we know our conversion factors. We said that we have 1/60th of a degree is equal to 1 minute, and 1/3600th of a degree is equal to 1 second. So we have 45 degrees plus 10 minutes. 10 minutes, and that minute is 1/60th of a degree, plus 15 seconds, and those seconds, each second is 1/3600th of a degree. Sorry, wrong symbol, of a degree. So I know I have 45 full degrees, and then this is going to represent my decimal. Now I'm going to use my calculator to do this. And I don't want to round off until the very last minute. So let me grab my calculator. So I'm going to do 10 divided by 60, I know is 1/6. So I can either do that, go ahead and do 10 divided by 60 or 1 divided by 6. That gives me this decimal. And then I need to add to that this next one, 15 over 3,600. So I'm going to say plus and then open my parentheses just because I want to make sure my order of operations are correct. And this is the decimal that goes behind that 45 degrees. So I need to round to 4 decimal places, which gives me 45.1708. I'm going to leave it at 8. I don't need to round up. So 45.1708 degrees. All right. B is the same process. So we have 35 degrees plus 15 minutes out of 60 to make a degree, plus 27 seconds out of 3,600 to make a degree. And you plug that into your calculator and round it off to 4 decimal places. That's what you should get. Okay, for C and D, we're going back the other direction. We're starting with decimal degrees, and we need to change it into minutes and seconds. When I was changing from minutes and seconds to decimals, I'm dividing. When I'm going the other way, I'm going to multiply. So I've got 12 degrees. That's my full degree number right there. And then I've got that decimal 87. So 87, and then I'm going to multiply that by minutes because that's gonna get me from decimals to minutes. Now when I do this multiplication piece right here, I get 52.2 minutes. You want to see that? I've got 0.87 times 60 gets me to 52.2. So it's 52.2 minutes. So now I've got 12 degrees, 52 minutes, and I need to pick up with this 0.2 and change that to seconds. I've got 0.2 minutes. Now we've already, or 0.2 minutes, we've already multiplied it times 60 once. So we don't want to multiply it times 3,600. 60 times another 60 is what gets us to seconds. Well, 0.2 times 60 is 12. So we have 12 degrees, 52 minutes, and 12 seconds. 12 degrees, 52 minutes, and 12 seconds. All right, let's do another one. We'll go ahead and do this one together. We're going to convert 1.53 degrees into degrees, minutes, and seconds. Well, we know we have 1 full degree, and then we have a decimal 53 that we need to turn into minutes. So if I multiply that right here, I get 31.8 minutes. Well, there's my degrees, there's my minutes. I need to take this piece, this 0.8, and turn it into seconds. So I'm going to multiply that times 60 seconds, and I get 48 seconds there. So the result is 1 degree, 31 minutes, and 48 seconds. Okay, we're going to stop here and pick up in our next video to talk about radians.